Here's an opportunity for you to practice with estimation skills. So, one of the questions you might be asking yourself is why should we practice our estimating skills, especially since most of us have a handy calculator, even in our cell phones, let's say. So think about why we should use estimating skills. And one reason is because estimation is a part of our everyday experiences, such as buying groceries and trying to stay within a budget, or splitting costs. Say you purchase tickets for a group of people, or you're having food out with friends, and you don't want to end up paying for it all. So you want to split it, but maybe it doesn't have to be so perfect. So estimation skills can come in very handy there. And then another area where we often encounter estimating is with contractors or consultants when they are doing a job for you and they don't know exactly what they need to do, but you want to get an idea of what you're going to have to pay. So estimating a bill before a job is actually done can be very helpful. As a student, estimation helps you determine if your answer is reasonable. So it's always good to maybe come about a problem in a variety of ways. So a calculation and an estimation. And estimation can actually help you check for computational errors because your calculator can only do what you tell it to do. So if you made a mistake there, it's good to have an idea of what you're expecting. And then if your calculator is way off, you know that you may have entered in a number incorrectly. And then often we need to get things done, say, quickly. So mental math or estimation skills can be very helpful when we need to get a job done in time constraints. Areas we can use computational estimation is with operations such as addition or subtraction, multiplication or division, and then also percentages. And then units, we could use computational estimation when we're trying to estimate a length of time, a length in terms of centimeters, miles, inches, etc. And then estimating money, as we talked about with, say, buying groceries. There are different estimation strategies, and we're going to focus on several of these. So, one is just rounding for ease. So, there are times when a number could be, say, very large or changing often or both. So, estimation or rounding could help us make this more understandable. Estimating an expression, and we're going to talk about two different ways to estimate an expression. And one of them will also entail front end estimation. And then finally, we're going to talk about compatible numbers. So, a way we could use percentages to estimate an end value is maybe to convert percentages into fractions. And then another way is to use benchmarks with percentages. And benchmarks are things that you can go to because they're, say, easier to work with, such as 10% or 25% or 33% or 50%. And we're going to see an example of two of those. Our first example is just looking at rounding for ease. So as of March 17th, 2021, the current national debt was about, and that's a huge number, is it? So we want to think about our place values there. So starting from the right, we have our hundreds, thousands, millions, billions, and trillions. So it's over $28 trillion, but it is changing drastically every second. So we could say the national debt is about $28 trillion. Or we could also say it will soon reach $28.1 trillion. And those are both estimations because we don't ever know the exact value of the national debt, but it really helps us understand how large the national debt is currently. So both of those are true, and they used estimation techniques to make reasonable and accurate statements. The next example is going to focus on estimating an expression. So our expression is 11.8 plus 99.5 minus 26.8. And if I wanted an accurate result for this expression, I would definitely probably pick up my calculator. But I just want to know about what is that amount. So one thing we could do is we could just round to the nearest tens. So if we round each number to the nearest 10, then 11.8 is closest to 10, 98.5 is closest to 100, and 26.8 is closest to 30. So if we use each of those rounded numbers, then we have an estimate of about 10 plus 100 minus 30, which is 80. So a good estimate for this expression is 80. Now, another way to tackle the same expression is by using front-end estimation. And front-end estimation is a particular way to estimate sums and differences by only adding or subtracting the numbers in the greatest place value. That's why it's called the front end. So if we're again estimating that expression, then the greatest value we want to look at is for the first number, it would just be that 1. So we would round that to 10. Now, this is a little bit different than before. We're only looking at the first number, and it's a 9. So we're going to say that is 90. And then for that last number, again, we're only looking at the first number, which is a 2. So we're going to estimate that to be about 20. So if we're rounding each number, we now have 10, 90, and 20 for our estimates. And when we combine those with our operations, what's interesting is we still get 80, even though we used a different technique. And the last technique we're going to look at, we're going to split this into two different types. So one, we're going to look at using compatible numbers, and we're going to focus on fractions. So we're going to estimate the sale price of a sweater where the original price is $28.95, and it is on sale for 33% off the original price. So we want to recognize $28.95, not an easy number to work with without our calculator. So we could say that that's very close to $30. So we're going right back to technique number 1, where we're rounding for ease. Next, we want to notice that 33% is very close to 33.3 repeating, which is equivalent to 1/3. Now, these two numbers actually happen to work very well together because 1/3 of 30 is 10, and $10 off of the original price of $30 gives you a very good estimate for the sale price of the sweater, because $30 minus $10 tells us that sweater is going to be about $20. And our last estimating example, we're still going to use compatible numbers, but in a different way this time. So the Jungle Ultra is a crazy marathon held in the Amazon rainforest in Peru, and it covers 143 grueling miles. Now, checkpoints are set up at approximately 4% intervals of the total race. So we're going to use our estimation skills to determine how many miles a contender would have to travel before encountering a checkpoint. So we're going to travel a total of 143 miles and we're going to encounter a checkpoint so we can make sure we're okay, get some water, maybe some band-aids, etc., every 4% of the race. So we want to think about the fact that 4% is almost 5%. And 5% is half of 10%. 10% is what we call a benchmark because it's a nice, easy number for us to work with. 10%. So 10% of 143 miles. 10% of 143 is about 14. Half of 14 is 7, because remember 5% is half of 10%. But remember, the checkpoints are only at 4% intervals, which means we would expect a checkpoint to come up a little less than every 7 miles.